Hello guys, this is day 11 of our daily push-up challenge. So we only have 2 weeks left and then we're finally done. But again, while doing push-up, we're gonna be solving some Putnam problem. This one right here is a problem from 1991, I believe, and yeah, Putnam 1991. And it reads: suppose f and g are non-constant differentiable real-valued functions on R. Furthermore, suppose that for each pair of real numbers x and y, f of x plus y equals fx, fy minus gx, gy, and then gx of plus y equals f of x, gy plus gx, fy. If f prime of 0 equals 0, prove that fx squared plus gx squared equals 1 for all x. Okay, so let's do 5. 1, 2, 3, 4, 5. Yeah, it really reddens your hand, But yeah, let's not forget to write the number of push-ups that we've done. So what I'm seeing here, what we can do is to extract something like the sum of the square of both functions. I'm thinking of squaring f of x plus y. So this gives us f of x squared, f of y squared, minus 2 f of x, f of y, plus gx, you still have a factor here for the second term, gx, gy, and then you have plus gx squared, gy squared. Of course, we can also square g of x, y. This will give us f of x squared, g of y squared, plus twice f of x, g of y, g of x, f of y, plus g of x squared, f of y squared. Okay, so we have that. 6, 7, 8, 9, 10. Okay, and then here we can add this to this expansion that we've done. So we have f of x y squared plus g of x y squared. So this will give you a term f of x squared, f of y squared, plus g of x squared, g of y squared. Of course, the cross terms will cancel because in the first one it's positive, negative. In the second one it's positive. So this is plus f of x squared, g of y squared, plus g of x squared, and then you have f y squared. And then maybe we can factor out, let's see, f of x squared. So that gives us fy squared plus gy squared. And then let's also factor out gx squared. So that should give us fy squared plus gy squared. And then finally, we can factor out f of x squared plus g of x squared multiplied by fy squared plus gy squared. Okay, so now I've extracted the sum of the square of both functions, and then they're related when evaluated at x, at y, and then x plus y. But I think we need also to use the fact that the derivative of x when evaluated as 0 is equal to 0. 15, 16, 17, 18, 19, 20. Okay, so that's oh wait, I think it should be 11 to 15. Yeah, so next we start at 16 to 20. But anyway, yeah, so like I said, it looks like we're going now nowhere unless we use the fact that f prime of 0 equals 0. So what I'm thinking is, let's get the derivative with respect to y of this guy. Okay, so this is equal to f of x, f prime y, minus g of x, g prime y, and also the second term, g prime x plus y equals f of x, g prime y, plus g of x, f prime y. And then we set y equals 0, and then note that f prime of 0 equals 0. That's given in the problem. Okay, so we are left with f prime of x equals, the first term is 0, so you have negative gx g prime 0, and then for the second one we have g prime x equals f of x g prime 0, and then the second term is of course 0, and again we are at 15, so 16, 17, 18, 19, 20. Okay, so 20, 5 more. Okay, so from here what I can do is I can solve for g prime of 0, right? G prime of 0 is equal to minus f prime of x over g of x. So therefore, g prime of x is equal to f of x multiplied by negative f prime x over g of x. Okay, this we can write as g prime of x, g of x, equals negative f prime of x, f of x, which simplifies to f prime x, f of x, plus g prime x, g of x equals 0. And note that we've seen something similar to this form in our, I believe, in the problem where we solve functions with equal derivatives. I think that's the title of the video, right? Note that if I introduce a factor of 2 here, 2f of x, f prime x, plus 2 g of x, g prime x, and of course I can do that because the right hand side is equal to 0. Note that this thing, the first term is just the derivative of f of x squared, right? So it's the derivative of f of x squared, while the second term is the derivative of g of x squared, right? When you use so that's plus. Of course, the right hand side will become some constant c, right? Because the derivative of c will be equal to 0. So now we are at 20, so this is the last leg of our push-up. 21, 22, 23, 24, 25. Okay, so now what? So we've established that the square of f of x plus the square of g of x is equal to some constant, but we want to show that it is equal to 1, right? The one I'm underlining right there. So what that means is, so we know that our functions are real and that our functions are not constant. Okay, so that implies that, so look, since both terms are squared, c is greater than 0, right? The only time that it will become negative is like f of x or g of x are like functions of complex numbers, but they're not, they're real valued functions. The only time that c will become 0 is when f of x and g of x are themselves 0, right? But since they are non-constant, okay, since they are non-constant and they're being squared, they can't be negative. Therefore, from here, we see that c is not equal to 0, okay? But we know that the sum of f of x squared plus g of x squared is equal to c. So I think we can go back now to our to the property that we found here, okay? The property that we found, that we derived here initially, the fact that the sum of f of x plus y squared plus g of x plus y squared is equal to the product of f of x squared plus f of y squared, okay, this is g of x squared multiplied by f of y squared plus g of y squared is equal to this guy. Okay, let me check. Yes, that's the property. So that means, look, in here we've established that when the sum of both functions evaluated at the same point squared is equal to some constant, correct? Therefore, in here, the left-hand side will just be equal to 0. C, the constant c, equals c multiplied by c, okay? So c is equal to c squared implies that C is either equal to 0 or equal to 1. But then we've established that C is not equal to 0 from the one here above. So therefore, Z is equal to 1. C is equal to 1. And therefore, finally, we were able to establish that since f of x squared plus g of x squared is equal to that constant, and that constant is we've shown to be equal to 1, then we've proven the thing that we want. That is f of x plus g of x, f of x squared plus g of x squared is equal to 1. Okay, so this has been, I think this might be the longest problem that we've done yet, but yeah, anyway, this has been day 11 of our daily push-up while solving some Putnam problem. We're at day 11, 2 weeks to go. Thanks for watching. I'll see you next time. Bye-bye.